Hi students, this is Neeraj Bansal and welcome back to my YouTube channel. Today we are going to do the topic oscillation, right? And if you have any doubt or if you want to contact me, the number is given right there at the. So let's start with oscillatory motion. So for starting with oscillatory motion, we need to understand what is periodic motion, right? Periodic motion. Motion which repeats itself after regular intervals of time is called periodic motion. So when I'm saying periodic motion, any motion can be periodic motion. Let's say you're going to school daily, that is a periodic motion. Earth is revolving around the sun, that is the periodic motion. Earth is rotating on its own axis, that is a periodic motion. But can we say all periodic motion or oscillatory motion? No. So in order to be an oscillatory motion, two things are necessary. What are those two things? First, there should be mean position. And second, there should be restoring force in the medium. Right? Let's say this is a block. If you push this block, it will come here, right? But will it come back? No, it will not come back. Why? Because there is no restoring force which can bring it back, right? So no restoring. Just imagine if this block would have been attached with this spring. So what would have happened? If you stress this block would have become like this, and then it would have come back, right? Because there is restoring force in the medium. Clear? So now let's talk about how this motion works. Got it? So let's say this is my pendulum. First it goes like this, then comes back like this, goes like this, and then comes back like this. This is called one complete oscillation, right? This is called mean position, and this is called extreme position. Got it? Then we can represent it like this. So this is the graph of the sine. This in the beginning it's like here, and then it goes to the maximum, come back to the zero, then goes to the maximum, the negative direction, then again come back to zero, right? So this thing is called amplitude, and this thing is called time period, right? So how can we define amplitude? maximum displacement around mean position score. Then let's talk about time period. Time taken for one complete oscillation scored 90. Is this clear? Now let's talk about the position. See, when you do V equal to U plus 80 half 80 minus U is equal to S, what actually you are doing? What you are doing in that case is you are trying to predict the position of the particle, the velocity of the particle, and the acceleration of the. So when we talk about the equation of the oscillatory motion, we say F is equal to minus kx. That means, or rather, first we should say F is directly proportional to negative x. Why negative x? Because restoring force is always in the opposite direction of displacement. F is equal to minus kx. If you divide both sides by m, become F is equal to negative k by m, or rather F over m. This is x, or x negative 1. This is called equation of oscillatory. So let's try to find what is my position of the particle at any time I know x is equal to x naught sine omega t, or x is equal to x naught. I can use either of the two, but you must be wondering why I'm using either of the two. First, we need to understand what is this omega. Omega is 2 pi by t, right? So let's say my motion starts at t is equal to, so x is equal to x naught sine omega times give me x naught times 0, which is 0. And if I'm putting x is equal to x naught cos omega times 0, which is x naught cos 0, which is, so that means I'll use sine function when I am starting from mean position, and I'll use cos function when I'm starting from the extreme position. Right. So this is position. Now I want to find my velocity. So velocity is equal to dx by dt. Let's differentiate it. D by dt of x naught sine omega t, which will give me x naught omega cos omega. This is my. Now let's talk about acceleration. Acceleration is equal to dv by dt, which will be d by dt of x naught omega cos omega t, which is x naught omega d by dt of cos omega t, which will be nothing but x naught omega square negative, then sine omega. So now I know x naught sine omega t is x, so this is equal to negative omega square x naught sine omega t, which will give me negative omega square. From here we reach to now for velocity. What is my velocity here? My velocity is x naught omega cos omega t, right? Squaring both the sides, in place of cos square omega t, I can write 1 minus sine squared omega t. I can write x naught square omega squared minus x naught square omega square sine square omega t. So this is x naught square omega square minus omega square times x square, right? So this will become omega squared times x naught squared minus x squared. So we taking under root of both the sides, omega under root of x naught squared minus x squared. So this is my velocity, this is my acceleration, and this is my displacement, right? So I want to see what happens at equilibrium position with my velocity and x, right? So at equilibrium position, my x is equal to 0, right? So p is equal to omega under root of x naught squared minus 0, which is omega under root of x naught squared, which is omega. I can say my velocity is maximum at equilibrium, right? Then what happens at the extreme position? Velocity at extreme position, x is equal to x naught. So v is equal to omega under root of x naught squared minus x naught squared, which is 0. So my velocity is 0. Velocity is equal to 0 at extreme, or rather, yes, my velocity is 0 at extreme position. Let's talk about acceleration. So my acceleration is equal to negative omega squared x. So at mean x is equal to 0, so acceleration is equal to 0, right? At extreme, acceleration is equal to negative omega square x, is negative omega square x is maximum. This negative sign shows that acceleration is in the opposite direction of displacement. Got it? So I hope this topic is clear to you here. In the next video, we will talk about the time periods of different kinds of oscillators, and then the energy, the oscillator, which is the kinetic energy, potential energy, and right. This we'll do in the next video. And in the meantime, please do subscribe my channel.